lot of work, a lot of fun, and people online too. So welcome. If you've never been to USC, this is the Arnold School of Public Health Discovery Building. You're in the computer labs, like I just mentioned. There's just a few things we need you to help us with because the system is so connected. If one of those things get damaged, it's a lot of work and a lot of money. So we apologize if we make you put your things out there. We will have logistics. Dr. Yanan will come up later and she'll introduce herself in the break. But if you need anything, ask logistically. If you come out the door, you make a right, you get to the female restroom first. You go past that restroom, you go past the elevator, you make another right, you get to the male restrooms. So that's the first thing. Second thing is, in an hour or so, on the third floor, you will have access to pastries and coffee just to keep you going. You get access to it during the whole day, lunches on your own. So please, they'll give you a break. And then you can come back, find a place to sit, and have that. We'll be walking around as much as we can, but the Yanan will be here. You have a wonderful
Elena.
She'll introduce herself when the time comes. But again, on behalf of INBRE, welcome and enjoy your summer workshop.
Great, thank you, Becky. I appreciate it. We may need a password up here. Yeah, so welcome everybody. My name is Alex McLean and I'm going to be the instructor taking you through whatever part of this you're going to do. Some are doing all 3 weeks, some are doing only 1 week, some are doing 2 weeks. So whatever you're doing, I'm excited you're here and excited to teach you some about data science, statistics, biostatistics, all that kind of stuff. And I have a lot of respect for all of you coming here in your summer breaks to learn a little more and get some more skills. So I absolutely want to make this worth your while. I'm a professor of biostatistics here. I have 2 helpers that are going to be helping us out with the coordination and answering your questions. Dr. Zhang, she's I think downstairs trying to help people find the room. We have Elena back here. Elena, you want to introduce yourself real quickly?
Hi everyone, I'm Elena. I am just going into my 2nd year of my PhD and I'm going to be the TA for these 3 weeks. I'm really excited to be here and to help you guys out in any way I can.
Great, thank you, Elena. And I'll have Yanan introduce herself when she comes in. Okay, so the first most important part for you is to initially to get on the GitHub page for this course. It's where all the materials are going to be. So if you have the syllabus, the GitHub site is right here. And you can just copy and paste that into your browser. If you do not, what you can do, you can just go to Google and you can GitHub my name, Alex McLean, GitHub, and the first link that comes up in Google will be my GitHub page. That will take you to something that looks like this. So GitHub, Google search GitHub Alex McLean GitHub, and then click repositories. And from there, after you click repositories, you'll see INBRE BIOS Summer 2026. Click that, and it should look like this here. Anyone having any issues with that? If you're online and you're having issues with that, just say so in the chat, and Elena can help you out. Everyone get there? Yeah. Okay. So for the syllabus, you can click on it. It's right here. Okay, so getting to the syllabus, again, hopefully you're at the GitHub page now. Click on the INBRE Biostatistics Summer 2026 syllabus. it's gonna look like this, and you just click this little down arrow right here, and that's gonna download the syllabus for you. So that's a good place that we can, start talking about things. Okay, so as I said, there's 3 weeks available for this course. Some of you are going to be doing 1 or 2 of these. Some of you are going to be doing all 3. The first week that we're going to talk about, this week, we're going to talk about the foundations of data science in a program that's called R. And what we're really going to focus on this week is getting what is R, first off, downloading R onto your computer, onto your laptop. How do we read data into R? How do we manipulate data in R? How do we show figures in R? All kind of things like that. We'll talk a little statistical inference, some t-tests, some correlations, basic things like that towards the end of this week. But mostly we're going to be talking about the R program, which is going to be super helpful. Because then when you get data in the future, you're going to have such power with that data, be able to read it in and to show figures for it. It's probably the most valuable part. Week 2, we're going to go through a lot of statistical modeling. So there we have some outcome, we have some exposure we're interested in. For example, we have age and systolic blood pressure, something like that. How do we relate these 2 together? How do we say these 2 are related? These 2 are not related, something like that. We're going to go through a lot of logistic regression models. Week 3, we'll talk about bioinformatics and high dimensional data, advanced topics where we'll talk about genomics workflow, differential expression, dimension reduction, penalized regression. So we'll get into some advanced statistical models that are particularly useful in biology when you have biological data, genetic data, because that was a lot of the folks that were interested in the course. Here are some of the objectives for this week. Our kind of most important ones. Work comfortably in R and RStudio for data analysis and visualization. Import data, clean data, reshape data, join data sets together, all that kind of stuff. Plotting, and then statistical inference. Those are the top 4 are going to be the main ones we're going to focus on. Okay, so as I said, all course materials are going to be on our GitHub page. A couple of textbooks there if you're interested in doing more software. We are going to get into to that. There's no real credit for this workshop. There's no formal grades or anything like that. There are going to be lab assignments. We're not going to have one today. There's going to be some exercises you can work on today, but we're not going to have a formal lab assignment today. These will be completed, and you'll hand them back into us. And the last week, we are going to have a capstone project. So if there's no grades, why do we have lab assignments that you hand back to us? Well, we have that because if you complete at least 75% of the lab assignments, you get yourself a very fancy certificate, okay, that has my signature on it and someone else's signature on it. So it's pretty good, right? I mean, frame that, put it wherever you want, laminate it, you know. So that's why you would do all the lab assignments to get the certificate. Okay, any questions so far on this? Good, okay. So these are kind of some of the course schedule, some of the labs that we are going to do. You can see what we are going to do today. And if you're here for all 3 weeks, you look over these topics, you're like, hey, there's something I would like you to throw in there. In week 3, particularly, let me know. Yeah, because I think we kind of had weeks 1 and 2 worked out, but week 3 we're going to be a little more flexible. Okay, we have a class Slack channel. that we can use to better communicate among all of us. I'm on it, Elena's on it, Yanan's on it. So if you're doing the lab, something you're unsure about, you can post it on there. Also, we have the Zoom channel, so you can always post in the Zoom channel, especially for the folks that are online, but you can use either one of those. So I like doing things through a Slack channel versus email because not everyone sees it, right? So you can see what other people are asking, and you can say, hey, you know, I had a similar question to that. So I think this link right here should allow you to join the Slack channel. I did create it a few days ago, so if it doesn't work, I can get a new one and I'll have that ready by this afternoon. I'm not going to post anything on it today. Any questions about any of that? Okay. All right, and then just some standard stuff. Okay. So let's go back to the GitHub page. So right now, I think the best thing for you to do with this GitHub page is to download the whole thing. Okay, download the whole thing. So to do that, go over to this green code button and hit that down arrow. And what you're going to do is you're going to just say download zip. Okay, that's going to download all the material that is on this GitHub repository. And it's got all of week one, all the stuff from week one already in there. So then you don't have to keep going back and forth and downloading things. When we start week two, we'll have some new stuff there. But just go over here, click download zip, and put it wherever you want to. I'm going to put it in the documents folder here, and double click that. Okay, boom. You're going to have the syllabus there. All the stuff is going to be on there. So for the first thing we're going to use, those are going to be the slides for week one. We'll put that week one foundations, day one orientation, and then day one slides if you want to follow along. But I will also go over, I have them open here, which you can follow on the stuff. Anyone have any issues with that? Did that work out okay? Yeah. Good. Any questions online or anything? Okay. All right. Some of this stuff we've gone over. So 3 weeks, we're going to be at this 4 hours a day. The morning is really going to be more of a lecture discussion type situation. We'll go for an hour, so we'll be in here until 11. We'll have a 15-minute break where there's apparently pastries and coffee. I'll show you guys where that is. And then we'll come back. We'll have 45 more minutes till 12. 12 to 1 we have for lunch. And there's a number of places around here you can check out. My daughter just started working at Pokey Bros, which is not too far from here. So if you want to walk down there, which I may do. And then we'll come back here at 1. 1 we'll start the lab. The format of the lab, not today, but the rest of the days. Today, we're gonna be talking for most of the lab, but the rest of the days, the format of the labs, I'm gonna be talking for maybe 20 minutes, introducing what we're gonna do in the lab, and then you guys are gonna be on your own. I'm still gonna be here, Elena's still gonna be here, Yanan will be here, so you'll be able to ask questions. For those of you online, we'll be monitoring the chat, and we'll be checking for questions on there. but that's kind of your chance to kind of get your hands dirty and work with some of the data, do some of the things that we've been demonstrating throughout class. Any questions about any of that? Okay. Okay. Over this part. There is a, if you're familiar with GitHub, you've used it before. You can also clone the repository that will like automatically update when you do that. But if you're not familiar with GitHub, don't worry about that. Some of the topics we'll cover, a lot of them. So I would like you to attend, participate actively. Please ask questions if something's not sure. When people don't ask questions, I just keep going. You know, I figure that everyone understands things, and then we can kind of get in a bad situation where you can't ask questions because you don't know what to ask, right? So as soon as you have a question, please raise your hand. It gives me important data. Like I'm a statistician, I like data, so it gives me important data to understand what you guys, what's hitting, what's not hitting. So please ask questions. The coding exercises that we do, some of them are going to be challenging, I'm sure. I remember when I took some first coding classes, they were not easy. But you're not gonna break anything, right? So when you're working through these things in R, you're not gonna break your laptop. You're not gonna, put any viruses on it or anything. So don't worry about making mistakes. Okay, we all make mistakes. I've been using R for over 20 years, and I make mistakes every single day with R. I'm not lying to you. And I use AI sometimes to help me out with R code. You know what? AI makes mistakes too. It's complicated stuff. It's very easy to make mistakes. So don't let it frustrate you. Don't worry about it. Just try to learn from them. The labs, this is really where you guys will kind of get this stuff. That's really where you're going to get your hands dirty. Try to do those on your own as much as you can. If you're, using Google, using ChatGPT, whatever, to finish these labs, then why are you here, right? I mean, there's really no point to doing that. So try to learn these on your own. Certainly, do I use AI to help me out in coding? 100%. I 100% do, and I recommend you do too. But for now, I would say just try to push that away and try to get these things done yourself. So what to expect from me, Elena and Yanan, a supportive learning environment. We'll have some good biological examples here, so we'll try to make these of interest. This is School of Public Health, so mostly we're going to talk about public health stuff. We'll try to explain things clearly so that we're not using statistical jargon. We'll try to explain them in language that everyone can understand. We'll teach you these things, and we'll help. When you do have mistakes, we'll be there to walk you through things and to show you sort of where you could be making some issues. So that's very important. You're not expected to memorize everything. So, for example, we're going to learn how to create figures. I don't expect you to memorize the code to create a box plot where you have different box plots for some categorical variable. I don't expect you to memorize the code for that. I don't memorize the code for those things either. What I want you to know, have some idea of what R can be used for. So then later on, when you're thinking of something, you're like, oh yeah, I think I can do something like that with R. And then what the actual specific code you need, you can look that up. You can use Google, you can use AI to sort of like guide you to the way. But what we need you to know is sort of kind of what is possible. So it's more the concepts that I want you to sort of memorize than the coding or anything that we're going to be doing. Know what's possible, know the big picture items, and then you can fill in the details later on. Any questions about any of this? So we're going to be talking about data science. What is data science? Well, it has statistics to it, probability, data. It has computing. So there is like this computing side of it. So R is what we're going to be using here to do our computing. And then the subject matter expertise. And this is where all you guys come in. I don't have really any subject matter expertise. I'm a statistician. I kind of work with the people that do have subject matter expertise, and we collaborate together to answer questions. But that's really, one of the critical sides of it is the subject matter expertise. So this is where you guys all have your own subject matter expertise that you're bringing to the table, and hopefully we can add some of these other things to help you become somewhat fluent in data science. So the modern biology, the data sets that arise from studies, modern studies, they have a ton of data to them. Okay, electronic health records. So, we have hospital systems around here that, every one of us probably has an electronic health record somewhere. You're in some data set somewhere because of your electronic health record data. So really, it's an important data source that we can answer a lot of questions, a lot of public health questions with. Genomics is, probably the one that we're all most aware of that generates tons and tons of data, right? So you can have 500,000 measures of someone's genome, tons and tons of data. So that's one that we have a lot of data for. And it's a lot different than something like wearable sensors. So my watch here is always, it's got my heart rate on it, how many steps taking, has some other heart rate measures to it. A lot different than my genome. My genome, okay, that's one thing that doesn't change. My DNA doesn't change over time. Wearable sensors, different type of data where it's something that happens over time. Something we call longitudinal data or intensive longitudinal data. Environmental monitoring. Again, another type of data there, it's again longitudinal, but then it has a spatial aspect to it because we have environmental sensors in different parts maybe of the state of South Carolina. Medical imaging is one that's like genomics in that it gives us a very large data set. For example, brain imaging. We have a group downstairs. They work a lot with stroke patients, and they have a study where when someone has a stroke, they take a picture of their brain and they can see from that picture where the stroke occurred. Did it occur on the left side of the brain? Did it occur on the right side of the brain? And then even left and right, is it front, back? Every spot is going to have a different impact on it. One part may impact speech, but one part may impact your ability to understand speech. So some people, they'll have a stroke. They can talk fine, but they can't really understand. They can't really understand speech very well. And what they're trying to do, they're trying to use these images of people's brains to try to have a tailor-made recovery and rehabilitation program for them. And to think about, it's called personalized medicine, where you're taking in this image. Hey, where does this stroke occur? Where in the brain is it? Can we help the speech therapist help this person learn to talk, learn to understand more quickly? So a lot of this data is going to be very complicated, and we certainly need some data science and statistics to analyze it. And here's just some figures of some biological data. So some of the questions that we'll ask, and this is really more what we'll be asking in week 2 for those of you who are gonna join us. And this first one is really, more week 3. What genes impact are associated with a disease? So if we have the DNA of a whole bunch of different people, can we figure out what parts of the DNA are related to a higher prevalence of a certain disease, a certain cancer, maybe? And certainly there's been a lot of work around there. Does treatment improve survival? This was something we'll talk about in week 2, where we have data where we follow them until they have some event. That event could be death. That event could be relapse to cancer. So you're cancer-free, but then you relapse back into cancer. And we want to know, does a treatment lead to people surviving longer? Okay, do they have longer until they die or longer until they relapse if they have the treatment than not? Can biomarkers predict disease progression? It's kind of similar to the first one. Environmental exposures, that's something that is certainly of interest in today's day and age. Are there certain environmental exposures related to you getting a disease more, getting a disease less? When we have patients, can we predict those patients that are really high risk for a particular disease, those that are really high risk for a heart attack or a stroke or something like that? Can we use their data to do that? So a lot of these scientific questions we'll try to look at as we go throughout the course. But again, this is mostly week 2 and week 3 stuff. This is when we're modeling data and we're trying to connect things together. Week 1, we're not going to do that quite as much. We're really just going to focus more on the software side of things, learning R, and that kind of stuff. So the data that we have, this first week we'll learn on getting it in, looking at it, and sometimes trying to fix it in some certain ways. Data can have a lot of issues to it, can be incomplete, can have missing values. How do we deal with that? Can be noisy, can have mistakes in it. So some of the stuff we'll be doing when we're cleaning data will be to fix some of these issues, and then later on, some of the stuff that we'll be doing to model data will be accommodating some of these data issues that we have. So the process that we go through in data analysis, we always start with the scientific question. And for those of you who go on to our capstone project, that's always where your project should start from. I have a particular scientific question. Once you have that question, we can collect and organize data. Here, we're going to be getting a lot of data online. By the way, we have better access to data online than we ever had in human history. We have more access to data online now than 30 years ago there was data that even existed. So we have a ton of access to data online. We can answer a lot of questions with that data. So we have a scientific question. We have our data, explore and visualize patterns. We're going to get into that this week. So before we're modeling data, before we're trying to connect some things, first we just want to look at the data. What does the data tell us? Just basic summaries, basic figures. What does it look like? What does it tell us? Then we'll talk about fitting the statistical models. Again, that's a lot of week 2 and week 3 stuff, interpreting the results and communicating findings. Communicating findings, we kind of get back to the some of the exploratory stuff, some of the visualizations that we talked about in point 3. And this does create a sort of a flow that we have. Again, we start with the scientific question, we capture data, We'll clean it. What do we mean by data cleaning? We'll talk about that. Mungling, wrangling, some exploratory analysis. That's something that we are going to talk about here. We'll get into a little bit of inference this week, not much, but most of this is going to be week 2, week 3. Then we're reporting, we're summarizing our results, and a lot of times this leads to the next study. So we answered one question, but a lot of times when we answer a question, some other questions are going to arise, and we start the workflow over again. When we are doing a statistical analysis, something very important called reproducibility. Anybody ever heard of that before? That term? Yeah. So it's a well, can somebody tell me what they take that term to mean? If they're willing to.
That if you repeat the experiment again, the data will repeat itself somehow, or it will be close.
Yeah, yeah. So if we repeat the experiment again, the data should come out with the same answer, right? So we summarize the data, we do our modeling or whatever, we should get the same results when we do the experiment the second time as with the first time. Okay, that is reproducibility. In statistics, we actually have a smaller reproducibility, and it's called the within study reproducibility. So, what was your name?
Whatever.
Atefer, saying that right? Okay.
Whatever.
Atefer, okay. Now what she's saying is, okay, we do study 1, do study 2 the same way, we should get the same thing. But within study reproducibility, when we do study 1, someone analyzes the data. If we have someone else analyze that same data, they should get the same answer, right? I mean, that's even more basic than doing a study again. Does it happen? Not always, okay? Especially, there's even something smaller than that. When person 1 runs their code, they get a certain answer. When person 2 runs the same code, I'm not joking, they should get the same answer, right? Doesn't it seem like that would always happen? Does not always happen, okay? So we will get into the things we'll do in here are the goal is to have reproducible workflows that at the very least, someone who opens your code, runs the same thing, they get the same answer. I had this issue with one of my students once. We were running the same code, getting different results, and like it was driving me crazy. Used R for 20 years. I couldn't figure this out. What was happening was we were importing this data. He was importing it. He lives in Texas. I'm here in South Carolina, and R was using our native time zone, and so we were getting our results were shifted by 1 hour because we were in different time zones. So that was one of the more crazy non-reproducibility issues that I've had. But this is like it's going to be. I'll say this, it's harder than you think it is. It really is. It's harder than you think it is to just get the same result with the same code. Organize files carefully, save analysis scripts, document decisions, keep raw data unchanged, okay? You always have a data set that's raw, don't mess with that. Avoid manual copy paste workflows. So we'll get into a little bit of this today in the afternoon when we start. I'll introduce something called Querto that we're going to use to help us reproduce, to help us create workflows that have good reproducibility to them, that you can see everything, that's happening. So reproducibility has multiple layers. The ultimate layer is you do study 1, you do study 2, you get the same results. But within study, there are multiple things to it. Are two different analysts going to get the same thing? And there are 2 different analysts using the same script. Are they going to get the same thing? So document decision. This is one thing that we'll talk a little bit about when we first introduce R. it's called when we'll comment code, write things that, hey, this is why I'm doing this. We'll get back into that. And of course, this is super important because science is something that builds on itself. And the analysis that gets done, it has to be transparent, right? Because really, on my side of things, when I'm reviewing a paper, I don't see all the analysis and I don't see all the code. I just see what the results are. How do I know that that's that analysis is going to be reproducible? And this is one that I cannot I can't highlight this enough. You will forget what you did 6 months from now. It's 100% true. You feel like I'm writing this line of code. I'm never going to forget this. I mean, I can't tell you how many times I've gone back to my own code and been like, "What the heck was I doing here?" I have no clue. So this is an issue and something that hopefully we'll gain a lot with this week. So some of the things we'll do, some of the good habits, the R that we're going to use, you're going to have something called a script with it, which is sort of like a text file. They're all familiar with text files. So it's sort of like a text file where it has things that you did to get to the end result we have. So that's kind of number one in terms of the good habits. Organize projects consistently. So you notice that as you download the zip file from GitHub, so we already have some project organization here that, okay, we have week 1, and then inside week 1, we have day 1, and then inside there, we have a number of files there. So that's just kind of a start of organizing this in a way that that we know where everything is. It's not just one file. When I got my PhD, I had one folder and it was called dissertation, and everything was in there, from homeworks to my dissertation draft, to notes that I took and then scanned. So this is something I've come a long way with since my single dissertation folders. Naming files. This is honestly something I talk to my graduate students about. You think like, oh, these aren't really that important, but having projects that are organized consistently and having files that are named clearly and names that make sense, this is critical to me because a lot of times we're sharing folders. I jump on there. I kind of need to be able to orient myself pretty quickly. So these are two big things, not just for reproducibility, just for you as professionals as you go forward. These are great habits to have. Commenting, I mentioned that. Keep analysis readable. Future you is one of your collaborators. So I'm not saying like when I'm collaborating with my students, these things are important because I need to know what's going on. The future you is one of your collaborators. So when you go back, you want this to be easy for you 6 months from now, a year from now, so that you understand it. Because we got to learn about where we came from. Okay, so what is R? So R is a programming language designed for statistics and data analysis. It's used widely in a lot of fields. There's another one called Python. R and Python are the two most popular ways of doing data science and analyzing data. R, the one that we're going to use, is 100% free. So that's a great thing about it, that you don't have to pay for it. And it's a great program. Statisticians like myself, when we create new models or new ways of doing things, we will often create what's called an R package that we will make publicly available. So all the latest models that have been publicized, they're all freely available in R through these packages. large scientific community and ecosystem, so a lot of people that can help you out. And last few years, yeah, some Claude and ChatGPT are obviously big helps with those. So how we are going to run R is through a program called RStudio. And that's what today we'll download R and we'll download RStudio, and we'll play around with them some and see how they work. Yeah.
Does R have any advantage over Python? And what is the reason that you're learning this instead of Python?
Well, I mean, I think they're both great programs. To me, I think R number one is I think the graphics in R are better than Python. I think there's just more flexibility to them. I think like publication ready graphics, I think they can be very, very professional. And then besides that, and all the modeling that we're going to be doing in here, you know, it's kind of 6 of one, half dozen of the other. So, and the data cleaning side, you know, which one's easier on the data cleaning side, I can't really speak to that much. But when the real benefit of Python is really going to be when we're talking about some of the high level machine learning type approaches. That's where Python really has a benefit. More because the people that develop those, they use Python more than they use R. But for anything we're going to be interested in here, you could probably do them more. Yeah. So what makes someone good at data science? Certainly curiosity, persistence. Sometimes these things you're just going to want to, you know, reach your fist through the screen. I've been there. So you really have to be persistent when you're doing these things. R does exactly what you tell it to do, even if that makes no sense at all. So persistence is going to help. Attention to detail, as I said, one small little character here can kind of give you some issues. So detail is going to be important. We have to have a good idea of what our initial question is, and you never want to forget about that. What is your initial question? So you want to have some clarity in your scientific thinking. There's uncertainty in all the estimates that we get and all the figures that we produce, so you have to be comfortable with this. And debugging is something that you'll learn to do. We have a lot better debugging tools nowadays than we used to in the past. So we'll hopefully get a chance to learn those. Yeah, you're gonna get stuck. It's 100% normal. Some part, if you don't get stuck in any of these, then this class is probably too easy for you. But getting stuck is good because when you're out in the real world, you're going to get stuck. So you kind of have to learn how to get over those bumps. It's totally normal. Okay, so I think we're almost at 11 here. So why don't we stop here? We'll come back and then we'll start to install R and work on some of that stuff. Get into RStudio, talk about some of the details there. So it's about 10. Let's meet back here at 11:10. Okay, so while we're waiting, first thing we are going to do is install R. Has anyone here installed R yet? Okay, a couple people have. So click this, or just go to www.rproject.org. It's going to look like this, and from here you are going to click the CRAN button, CRAN. And then it's going to ask you what mirror you want to do. You can just click the first one, this zero dash cloud. Cloud, gosh, I forgot that. Click on that. And, then you're gonna see the different options. If you have, when you have Linux machines, if you have Windows, click download R for Windows. If you have Mac OS, you can click that one. You don't need to install it on here. It's already gonna be on there. And RStudio is gonna be on there, as well. But the only little challenge here, does anyone here have a Mac that they're using? Yeah, so if you go to Mac, there are two different versions of this. And do you know if you have an M1 or an Intel based Mac?
I think I know it's an OS based Mac.
So go up to the little Apple thing in the corner. There, you can just click about this one. Yeah. Yeah, so, yeah, you have an import, yeah, so you wanna do the Apple silicone one, this first one right here. Yeah. What's that? Chromebook? That's a good question. Let me. Could you search? I'm
Yeah.
not sure which one, I'm not sure which one to use for a Chromebook, actually. Everybody else doing okay with that? And then, once you download it, just go through the steps of installing it. It installs just like normal software does.
For the Chromebook, it says to enable Linux and then do it through that. Does that make
Do it
sense?
through Linux.
Yeah.
We. Give it a try, and if it doesn't work, we'll get you to log on to this, computer. And we can figure that out in the lunch break. I'll try to figure out how to do it today. On there. It's going okay for everybody else? Cool. Yes. You don't know. I don't. Go back to it. Okay. All right, so the next thing we are going to do, is, you can open R. Once you've installed it, here I'm gonna go down to R. You may see some different versions there. You can just, whatever version you just installed, and double click on that. And it's gonna look something like this when you open it. Try it out, make sure everything's working in its guy. Should be okay, yeah. Just the version you make as well. Because it updates itself.
I was also, as I was trying to figure out,
How does he get enter? I keep getting close up.
Okay, so when that works, you can close down that R window that you have. X that out. The next thing we're gonna do is install R Studio, and this is how we are going to actually use our R. So if you click on this link to install R Studio, scroll down here to install R Studio, click it down, click download R Studio for Windows or Mac, whatever you have. Download that and click on the installer to install that program. What? Like yours has the pictures of all one does.
Which version?
Like when I look at the notes on my computer up there, it doesn't have these pictures. I'm not sure why that's happening. Okay. Everybody do okay with that? Got our studio in there. So I'm really sorry, my presentation on here is not showing any of the figures. I can see from y'all's presentation that most of them are working.
What is that?
So did you get?
Yeah.
Okay, so you're good with that. So now go to our studios next.
Free.
Open it once more. Wants to tell you.
Yeah, and he said.
Okay, so Windows should be a .exe file, Mac .dmg file, and then once you have that set, you can open our studio. It should look something like this, and you can try it out. 1+1 get wd open close, and the last one to install .packages quote tidyverse, and then hit enter from there. And that's gonna take a little. What? That'll take a little time to. Reaching here and
Why's your name?
What's everybody doing? Let me check the chat.
Yeah.
Okay. Installed out packages, boom, that looks beautiful, yeah, we've never done it before. Yeah, let's get you under the, did you get the RStudio?
Yeah.
Okay, let's use that.
Okay.
Let's use that.
So,
Yeah, just, they're kind of basically the same thing, but.
yeah.
This
There.
one, it's a lot of nice little things. Then you do installed out packages, tidyverse, yours okay?
I think so. It was-
Looks like it's working.
Yeah. Practice the last stuff.
Yeah, it's a lot of stuff.
Oh, yeah.
And then.
I feel like I'm like hacking it. They play the facility.
Oh, yeah. Might have to break how long the robots inside shoes go together. Yeah.
Yeah, okay.
Yeah, I think we don't. No, no, so like, once you just want one package, I don't want to do that. Oh, it's making those.
I don't think it's just that.
Awesome, thank you.
That's very good.
Right. Oh, yeah, instead of showing the.
Yeah, it's copy paste. And postures. But I'll encounter when I feel like this, that's my posture. Yeah. And so that should be able to pack it. I noticed that I'm sitting like that.
Where?
It's not good. Pretty much. Yeah, for seventh grader, he's freaking fast.
Well, you got, that was in the, yeah, it's,
He's down his hair. He runs the work. It looks like it runs. Well, he's kind of over the purple. I know you could. All.
Yeah.
Package.
Okay.
He ran a college race.
Tidyverse, everybody,
Yeah, just.
okay? Elena, how we doing?
I'm not too sure. It's something's happening.
Okay, maybe we'll have to figure it out
Yeah.
during our lunch break. Okay, so now you're in RStudio. RStudio is where we are going to run R from. It's where we're gonna like make figures, where we're gonna import data. The R, okay, the first one we opened, we're not really gonna use that. So we're really only gonna use it from RStudio. It's a very nice environment to run your programs from. You'll see that there's four things in your RStudio, 4 panels. Okay, there's something called the source. There is the console or the terminal. We have this part over here as your environment, has your history in there. And then we have this part, this is where you can see your files, plots, packages, a lot of the help files are in there as well. So the source, let's show you how this looks on mine.
This way.
So right now I can't see the source. So if yours looks like this, like there's only the console over there, you can see up here it says source, it's just being minimized. But if I make that a little bigger, I can make it so that we can see all 4 of the panels, all 4 of the panels that we have. So the source, this is where we are going to write our code that we want to keep. This is like that text file that I mentioned, that we're going to have all these programs up there that we're going to use. Where these programs actually get implemented is down here in the console. So this is actually where they're going to be fed in, and this is actually what's going to be doing stuff. The environment, the history, connections, tutorial, I'm not going to use that much, pretty much throughout the week here. The only nice thing is the history. That keeps a record of all the things that you've submitted to the console. Sometimes you need to go back to that, but honestly, I don't use this really 99% of the time. Then down here we have files, so you can see all the files that are available in your working directory that can be useful. Help, okay, this is very nice. So as a program you don't know how to use, you can go over to this help. They have a search in there. You can put in a function and it'll tell you how to use it. And then also plots. So any kind of figures we create, they are going to pop up down in that bottom, part. Looks like we have some people in the waiting room. Okay. All right. So this is sort of the default this is the default way this is configured. I actually don't really love this way. Because when I'm in R, what I'm using mostly is this and this. And I don't like them, I don't know why you'd have them stacked right on top of each other on the same side of the page. So we can change that by going up to Tools and then going down to Global Options. And this is where you can change sort of how your RStudio looks. So I'm going to go to the pane layout here, and I'm going to switch this top right one to the console. And then the environment history is going to go down to that part, and I'll hit apply. And then you can see that now I have my script on the left-hand side, I have my console on the right, and that's most of the time, at least today, this is all I care about. I care about plots and help sometimes, but this is kind of for me, the way I like to do it. There are some other things in global options that you can do. For example, the appearance. You can change this so that you can have sort of some different color schemes. You can make it however you want it to look. I'm just going to keep the standard color scheme. To save and open files, we can go to File, click Open File, or excuse me, we can go to File, New File, and you see there's a lot of different types of files that you can open from here. to start, you can just use an R script. That's a good place to start from. We're going to use a Quarto document later on. Those are the main two that we are going to be playing around with. So this R script right here, this is where I can have any of the code that I potentially would want to save and want to come back to at another time. So this is kind of like, you can kind of think of it as your notebook, kind of like a notebook where like, hey, I'm saving things on here that I might want to come back to later on. And the console area over here, this is where we actually implement any of the commands that we want to do. Are going to be over in this console part. But when I want to save something, I don't have it in the console. I'll have it in an R script over here. So we hopefully you're able to do some of those. So let's say on this console side, one of the first things we had 1+1 get WD. That's something that we're gonna want to use. So if I'm on the console side and I want to run this over here in the if I have my R script and I want to run it over here in the console, what you can do, if you're on Windows, you can just hit Control Enter. If you're on Mac, you can hit Command Enter, and you can see it's going to get shot over to the right hand side. So as long as you are on that line, it's gonna run that line. If you want to run multiple lines, you can highlight all the lines you want to run, hit Command Enter, Control Enter, and it's going to shoot those all over to the console. You can see the results of those. Yeah, so you want to use this script for anything that you are going to want to save, even that you might want to save. So make your scripts verbose, have a lot of things in there, because anything in the console, once you close down R, it's gone. Okay, you can't recall what you had in the console before. Only thing you can save is what is on this left-hand side in that R script portion. Later, we're going to talk, we're going to use QMD files. So QMD files are what you can use to create more, well, for example, this document right here is a QMD file that I created from R. So this is something that's more official. Like, okay, I want to show my advisor some results. Okay, that's going to be more in a QMD file. It's more kind of like a final document, whereas an R script is like, okay, these are things I'm playing around with and I want to keep in mind. I want to save these things. A .qmd file is a little more final. We'll create one of those at the close of today. Okay, so for this .qmd file, you'll see these gray boxes here that have some R code in them. And if you put your cursor over there, you'll see there's a little button over here that you can click and it'll copy the code. So it's going to be very easy to copy and paste it over to your R script or directly into your R console. Someone's waiting. So R is a calculator. You can see just sort of the general way R is going to be for addition, multiplication, division, sine function is one of the ones. Pi, this is going to be equal to the number pi. If we pop that in there. R is going to follow standard orders of operations. So for example, 1/2 + 3 is going to give us 3.5. whereas 1 over parentheses 2 plus 3 is going to give us 0.2. So the parentheses are going to be important. Here it's going to apply the exponent first before multiplying. Again, basic order of operations gives us something different than multiply first and then apply the exponent. One thing we are going to do a lot of is we're going to create objects in R. So here, first off, this is going to be our first object that we create. Basically, we're going to say x is equal to 3 times 4. And you can see when I do that in the console, nothing comes up. But now what's happened is I've created an object in R that's equal to 12. So this x right here is going to be equal to 12. If I look over in my environment, you can see that now, okay, I have a value over here, x is equal to 12. And then if I write x, it's going to show me, okay, x is equal to 12. If I do 2 times x, that's going to be equal to 24. If I do x squared, that's going to be equal to 144. So R is going to take that value right there. It's going to hold it, and it's going to do whatever we want with it. So how I say x is equal to 12, notice what I use here. It's a less than sign followed by a dash. You can use an equal sign also, but the less than sign and a dash is going to be a little more transformable. So I also could say y is equal to, say, 9 times 5. That's also going to work fine. But the dash is going to be a little more transportable. There is a shortcut. If you use, if you're on a Windows, it's going to be Alt minus. If you're on a Mac, Option minus. That's going to give you this thing automatically. So if I hit Alt minus, boom, that sign is going to go in there right away. There's a lot of shortcuts in R that we're going to find out. That's one of them. When we create things in this class, when you create an object, you do want to call it something that's somewhat meaningful. So a lot of times that consists of more than one word. You can't just call something result 1, result 2. You want to have some meaningful names to the objects that you create. And it's good to have good conventions. So things you always use to create things. One of them is called snake case, where to connect 2 words, you do an underscore. So snake underscore case. Some people also like using camel case. So where every time there's a new word, you capitalize the first letter. Then you can kind of, you can somewhat read things. What you can call these things anything. Objects, they have to start with a letter. You can't start with a number. They can't contain numbers. They can contain an underscore or a dot. Also as well. So I can have W, or I can call this my underscore results. And when I read it in, it's going to give that to us. R is case sensitive. So this up here, I had lowercase x, but if I use capital X equals 45, we can see that x and capital X are not going to be the same. So it is case sensitive. That's not always the case with all the statistical packages. Some statistical packages objects are not case sensitive. This case in R that they are. And it's an easy way to make a mistake too. You know, if you have just one capital differently. That's why these conventions are important. You know, you notice in snake case, everything is lowercase. Okay, that's one of the reasons why we use that. So we're not mixing up capital letters and lowercase letters. So if you have a convention, all right, I just always use lowercase letters with an underscore in between words. Boom, you're going to be all set. Any questions so far? Okay, I know it's all very conceptual, at this point. So the next thing we're going to do is we're going to create what's called a vector here, which is just going to be a string of numbers, and this is something we're going to call x. So here x is equal to the numbers 42, 71, 4.2, 7.1, 2.8, so on and so forth. Some of the built-in functions that we can use in R, if I want to know the average or the mean of x, just the mean of x. I want to know median, variance, standard deviation, all these sample statistics that we will sometimes use, range, the difference of a range. So here, notice I'm applying two functions. So I'm creating a range, and then I'm getting the difference there. So the difference is the difference of 9.3 and 2.8, which is going to be 6.5. Here, doing the interquartile range, sum, CUM sum is going to be a cumulative sum. So it's going to take each number, and then it's going to add the next number, and it's going to add the next number. So 4.2 is the first number, 11.3 is the sum of the first two, 14.1 is the sum of the first three, so on and so forth. Cumulative product works the same way. Sort functions are going to be useful a lot because a lot of times we want to sort data to look at things that are the largest and the smallest. So we can use that. Descending equals true is going to give us something that starts with the biggest and goes to the smallest. Order and rank, these are sort of the opposites of what each other. Order of x, so the first element is going to say which element in x is the smallest, and the third element in x is the smallest. The sixth element of x is the second smallest, and you can go up and see that that's correct. Rank is going to give you the rank of each element, so this tells us that the first element of x is the third smallest. The sixth element of x is the second element of x is the sixth smallest, and the third element of x is the smallest. So on and so forth. So kind of opposites of one another. Rounding, of course, something we can do to make things look a little nicer. Floor, something when we do when we just want to round down. There's also a ceiling function that we can use if we want to round up. Oh, there it is. Absolute value, okay. Square root, log functions. When you do log in R, it means the natural log, not log base 10. Log base 10, you actually have to say log 10, and then exponential of all the numbers in X, we can do that as well. So these are just some of the basic mathematical built-in functions that we have. The length of X, that's going to tell us how many elements are in this X value that we have. Minimum, maximum. Which.min, this is one that's which.min and which.max. It's actually something I use quite a bit. All right, not just, don't just find me the minimum, tell me which one is the minimum, which element is the minimum. And same thing with the maximum. We're going to use that on day 6. Table is something I use all the time. So just, basic frequencies, okay? So you can see we have some, I have a vector here made with A's, B's, and C's, just how many A's, how many B's, how many C's, okay? Very basic summary. Tabulate is going to run somewhat similar to that. Now, most of these functions that I just gave are going to have an na.rn argument. So missing data in R are going to be, they're called NAs, not applicable, or not available, one of the two, I guess. So this, Okay, so this X with missing that I create right here, you see it has NA right there, has NA right there. R is going to treat those as though that's missing data. Different statistical packages use different values for missings. This is what R uses, NA. So then when I try to take the mean of something that has an NA with it, it gives me an NA back. Okay, and that's how it's made to work. So number one, that's going to tell you, all right, I have an NA in this variable. I can't calculate the average. You still can calculate the average of all the values that are not missing by setting NA.RM equals true. All caps on true. Okay, it has to be all caps. So that says, all right, remove all the NAs, calculate the average of everything else. And that is going to be true for most of the functions that I just gave you. So min, max, median, some of the others, sum, interquartile range, standard deviation, variance, any of those. If you have an NA in there, it's going to give you an NA back. You're going to have to add this argument NA.RM equals true so that it will ignore. Good? Good? Okay, so comments. This is one of the things that I mentioned is important to have in your code, like in your script, in your notebook. It's important to have comments. So when I do a comment, so for example, I'm going to copy this, I'm going to bring it over to my R script, paste it over there. So when I use this pound, the number sign, compute the average of 3 measurements. This is not something I can, so you can see, just ignores this line right here. This line does not get read over into R. If I did not have the pound sign there and I just had it over here, then when I go to run that, it's not gonna like that. So when you have the pound sign there, that tells R, hey, just ignore everything that's beyond that particular pound sign, and keep working. So comments are very important to use because those are notes that you're leaving yourself for 6 months from now. That, hey, why did you do this particular line right here? So code that is good has a lot of comments in it. Okay, and that's for you. It's for your collaborators. And remember, you are one of your collaborators. Your future self is one of your collaborators. So use a lot of comments in your code, not just why. Comment the why, not just the what. You can always figure out what mean X does. 6 months from now, you may not remember why you were computing the mean of that particular variable. Okay. All right, so vectors, this is the most simple form of data, okay? One variable, few values for it, right? So here, one variable, we have the primes that we created similar to the X value before. We can multiply this by 2, we can subtract 1, we can square it, we can do all those sort of useful things. When you want to create your own data, there are some useful things that you can do to create your own data. If you use the colon, the full colon, if I say 1:9, that's going to create a sequence of data that just counts the integers. Okay, so you can see that creates 1 from 9. Another way to do this, we can use this function called sequence, which has 3 arguments: from, to, and by. So here I'm telling it start from 0, go to 1, count by 0.25, and you can see that creates a sequence of data. Something that could be useful. We can also do from, to, and length out. That says, all right, here's where you're starting, here's where you're finished. How long is this thing going to be? Okay, it's going to be equal to 6. Repeat, R-E-P, repeat. What do I want to repeat? I want to repeat 1, 2, 3. I want to repeat it 3 times. And you can see we have 1, 2, 3, 1, 2, 3, 1, 2, 3. These are sometimes things that you want to add to your data set. Here we have something very similar where we said 1, 2, 3. but repeat each one 3 times. So that goes 1, 1, 1, 2, 2, 2, 3, 3, 3. Now, what we are mostly going to use in here are data frames or tables. Tables are very similar to data frames. Data frame is just the most common way to store rectangular data. Just think of a spreadsheet, right? A spreadsheet that you would open in Excel. This is basically what a data frame is going to look like. So we can let's copy this data frame and put it into our R here. This patient data in here. And then we can see the patient data, see what's all equal to. If I want to access one of these particular variables, say I wanted to access the age variable. So if I want to do that in the console, I can write patient data and then put a $sign there. And notice that RStudio kind of tries to fill it in for me. It says, all right, you want to look at patient data. What variable do you want to look at? You want to look at the ID, you want to look at the age, you want to look at the weights. So you hit $sign, it's going to fill that in for you. It's a very nice feature. So I can click age, hit enter. Okay, now I just have the age. So for example, if I wanted to calculate the mean age, I could just wrap mean around there. Mean of patient data is very nice. I was trying to fill in mean age. You go back. Oh, how did I do that? So if you want to recall the previous line, you just hit the up arrow. And I can change this age to weight. So calculate the mean age, calculate the mean weight. Summary is a very useful function that I use. One of the functions I use the most in R. It's going to give you a 6-number summary of every variable in your data frame. It's going to give you the mean, the first quartile, the median, the mean, the third quartile, and the max. It's also going to tell you if you have NAs in there. If you have NAs in a particular variable, there's going to be another thing that's going to pop up and it's going to say NAs 4 to however many NAs you have for that variable. So it's a great thing to do right off the bat to look at, okay, where's the range? What's the min and the max? How large? Is there any values that we know are not going to be are not going to make any sense here. So most of the time when we are working in R, we're going to be working with data frames. Okay, so some of the stuff we were looking at above, introducing vectors, but really when we get into this, when we read data in, it's going to come in as a data frame, and that's what we're going to be using it. Okay, we're going to stop for lunch, come back here at 1. We'll get into some of the packages. What do the different packages do? And then we'll start to create our first Quarto document, which will help us with our reproducibility as we go along. So have a good lunch. I'll see you guys back here at 1.